Good morning, dear students, and welcome back to our online class. We are doing Chapter 6, Electrolysis. And in our previous class, we have learned many things about electrolysis, their definitions, electrolytes, their types, and we ended our last class with types of electrodes. We learned in our previous class that electrodes are of two types. They are anode and cathode. An anode is a positive terminal electrode and cathode is a negative terminal or negatively charged electrode. In our today's class, we are going to discuss more about these electrodes and the chemical reaction taking place at these two electrodes with some examples. Although there are only two electrodes, anode and cathode, sometimes it becomes very confusing to remember which electrode has which electrical charge, whether it is anode, which is negative or positive, or whether it is cathode, which is negative or positively charged electrode. It becomes very confusing to remember the true nature of the electrodes. Today I'm going to tell you a very easy way to remember the true nature of these two electrodes, which you do not need to mug up. Now let us start with anode. Now anode starts with A, and from A we will remember addition. And symbolically addition is represented by plus sign. So anode is a positive terminal. A addition plus positive. So anode is a positive electrode. And we know that there are only two types of charge. They are positive and negative. So if anode is negative, cathode has to be, if anode is positive, cathode has to be negative. So this way it becomes very easy to know the true nature of the electrode. Now we know that electrolysis is a process involving ions. Now without ions, electrolysis process cannot take place because ions are the carrier of electric current in the solution. Therefore, whenever we talk about electrolysis, we also have to discuss about ions. Now we know we have studied about ions from class 7 onwards. Now ions are charged particles and they are formed either by the loss or gain of electrons by neutral atom. Now there are two types of ions again, and they are anions and cations. And anions are negatively charged ions, whereas cations are positively charged ions. Now, since electrolysis involves the movement of ions, now we have to now understand which ion moves towards which electrode. So let us go to our second stage of today's class. Now, we know the basic concept of charges, and that is opposite charges attract each other. Now anions, they are negative ions. So negative ions get attracted towards positively charged electrode. And which is that positively charged electrode? That is anode. So anions will move towards anode, whereas cations, which are positively charged ions, they also move towards oppositely charged electrode, and that is cathode. So how we are going to remember this relation again? It's very simple. We'll remember AA relation, and that AA relation is anions move towards anode, and CC relation, that is cations move toward cathode, and they are oppositely charged. Anions negative, anode positive. Do not get confused over here. cations are positive, whereas cathode is negative. So this is how we are going to remember, and many students, they have confusion understanding these two simple concepts. Okay, I hope I have made you clear about this concept. Let us take example over here. Anion, chloride ion, it is negatively charged ion, so it will move towards anode, and at the anode it will lose the extra electron which it is carrying as negative charge. So it will lose electron. That lost electron is shown over here, and it will convert into neutral chlorine atom, and this process is known as, what is this process known as? Oxidation reaction. Why oxidation? Because oxidation is a reaction which involves loss of electron. I hope you still remember the mnemonics or the abbreviated form of oxidation reduction reaction. GR, I told you to remember GR and LO. GR stands for gain of electron, which represents reduction, and LO stands for L, loss of electron, and it is oxidation. So here at the anode, loss of electron takes place, and what type of reaction is taking place over there? Oxidation. So at the anode, anions undergo oxidation reaction, whereas at the cathode, now cations will gain one electron. Over here in this particular example, it gains one electron. Sodium ion gains one electron and converts into neutral sodium atom, and this is a gain of electron process. So this reaction is a reduction. So at the cathode, which reaction takes place? Reduction reaction takes place. Let us see this whole thing with one example. Now, since in the electrolysis at the two electrodes, oxidation and reduction reaction takes place simultaneously, therefore the electrolysis process is known as a redox reaction. Let us take one example, electrolytic dissociation of sodium chloride. This is aqueous sodium chloride or molten sodium chloride. Now, when we know that sodium chloride is an ionic compound, and in solid state the ions are held together by a strong electrostatic force of attraction. But when they are dissolved in water, these strong electrostatic force of attraction becomes weak due to the effect of water molecules, as a result of which these ions now become free. They split into sodium ion and chloride ion. Now, when electric current is passed through this solution containing sodium ion cation and chloride anion, now at the cathode, sodium ion moves towards cathode, gains electron and converts into sodium atom, and therefore undergoes reduction reaction. At the anode, chloride ion moves towards anode, it loses electron and converts into neutral chlorine atom, and therefore it undergoes oxidation reaction. Now we know that chlorine cannot exist in atomic form. It is a diatomic molecule. Therefore what happens is, another chloride ion comes to anode, undergoes similar oxidation process, producing another chlorine atom. Now when these two chlorine atoms come together, they will now produce chlorine molecule at the anode. So the electrolytic dissociation of sodium chloride produces chlorine gas at the anode and sodium metal at the cathode. Now this whole process can be combined together and written as a single line chemical equation, balanced equation, and that is called overall reaction, redox reaction. So the overall redox reaction will be 2NaCl gives 2Na plus Cl2. So this is what the overall reaction during the electrolytic dissociation of sodium chloride. Now when we are talking about electrolysis, we are always talking about ions. because without ions, electrolysis reaction will not take place, since ions are the carrier of electric current. Therefore, now it becomes very, very important to understand two terms, and they are electrolytic dissociation and ionization. Although these two terms are related to ions, but they are different from one another. So what is the difference between dissociation and ionization? That we will discuss now with some example. Now let us first understand what is electrolytic dissociation. Electrolytic dissociation is the process due to which an ionic compound dissociates into ions in the fused state or in aqueous solution. That means it is the process in which ionic compound are made up of ions. That means ions are already present over there, but they are not free. So the process of making that ions free is known as electrolytic dissociation. Therefore, electrolytic dissociation process takes place in case of ionic or electrovalent compound. For example, sodium chloride. Now sodium chloride, we all know it is an ionic compound because it is made up of sodium ion and chloride ion. Now when they are dissolved in water, what happens? The water molecule breaks the ions which are earlier strongly held to each other. The water molecule helps to split or break these ions into free cation and anion. This process is known as dissociation. Okay, there are already ions. Splitting of ions is known as dissociation. Now let us see ionization then. What do we understand by ionization? Now ionization is the process by which polar covalent compounds are converted into ions. Please mark this word converted. This means that there are no ions in the compound. Non-ionic compound is converted into ions. That means ions are created. Ions are not separated, but ions are created. So the creation of ions from non-ionic compound, which in this particular case is polar covalent compound, is known as ionization. Let us take one example. Hydrogen chloride. We all know hydrogen chloride is a covalent compound and it is a polar covalent compound. Why it is a polar covalent compound? Let us understand over here. Now hydrogen and chlorine, they both are non-metals and they bond with each other, or they form a bond by mutual sharing of electrons. When they share one pair of electrons, they form one covalent bond. So in between them there are two electrons, so one pair of electrons. But the electronegativity of chlorine atom is slightly more than that of hydrogen. Therefore what happens is this chlorine atom will attract the shared pair of electrons slightly towards itself, increasing the electron density over chlorine. Hence chlorine acquires slightly negative charge. But this is not an ion. It only acquires a small negative charge. At the same time, hydrogen will acquire slight positive charge due to less electron density over it. Now, these small charges which are developed on hydrogen and chlorine atom, when they now get mixed with water, H2O, when they get mixed with water, now we know that water is also a polar covalent compound. Okay, so oxygen has slight negative charge and 2 hydrogen has slight positive charges. Now this poles of water attracts the opposite poles of hydrogen chloride towards each other. This oxygen will attract hydrogen. Okay, now as a result of which it will form H plus and chloride ion. Now here ions are created from non-ionic compound. Now this proton will now quickly move towards oxygen, okay, or water, and they combine together to form hydronium ion, H3O plus. So this is hydronium ion, and chloride ion remains as chloride ion. So that is why when we dissolve acid in water, we get hydronium ion as the only positive charge. Is that clear, boys? So now over here, what is happening? From non-ionic compound, ions are being produced, created, and that process is known as ionization. So there are differences between dissociation and ionization, and it is very nicely given in your textbook. I want you to read, understand the differences between ionization and dissociation with examples, which will be very useful for you to understand later concepts. Now we'll move on to our last topic of our today's class, and that is preferential or selective discharge of ions at electrodes. Now why we need to understand this term? Because sometimes in an electrolytic solution there may be more than one type of particular ions. For example, when we dissolve copper sulfate in water, when we add this to water, because we don't take solid substances as electrolyte, we take solution, and mostly we prefer aqueous solution. So when we dissolve copper sulfate in water, now copper sulfate being an ionic compound, it will break down into copper plus and sulfate ion. At the same time, water also ionizes. Now this is a polar covalent compound, so water will dissociate to produce H plus and OH minus. Now if you see over here, we have two types of cations, one copper and another is hydrogen. We again have two types of anions, sulfate and hydroxide ion. That means we have two set of cations and anions. Now all the ions cannot move. Like if we take cations, both copper and cations, copper plus 2 and H plus 2, H plus. Now both copper and hydrogen ion cannot move towards the electrode. And which electrode is that? AA, CC. So cation will move towards cathode. Now both copper and hydrogen ion cannot move towards cathode. Only one ion moves towards cathode. So out of these two, which one moves or gets discharged towards the cathode? That choice is known as preferential or selective discharge of ions at electrode. In the same way for anions, we have here sulfate ion and hydroxide ion. Again, two ions cannot move towards, anions move towards anode, AA relation. So two ions cannot move towards anode at the same time. Only one anion can move. So which one will move? That is again decided by the preferential or selective discharge of ions at the electrode. And we always come across more than one type of cation or anions whenever we are dealing with electrolysis. So that whole selection of discharge of ions depends on three things. They are: number one, the relative position of ions in the electrochemical series. So here we will again recall our electrochemical series of metals as well as non-metals. Number B, the relative concentration of ions. Higher the concentration, the amount of particular ion, more preferentially it will be discharged at the electrode. Lower the concentration, lower will be the preference of discharge. And number three, the nature of the electrodes, whether we are using inert electrode or whether we are using active electrode. On that also the preferential or selective discharge of ions of electrode at electrode depends. So there are three things you have to remember. They are relative position of ions in the electrochemical series, the relative concentration of ions, and number three, the nature of the electrodes. I'll just recall your electrochemical series of metals and non-metals, which we learn from class 8 onwards. Now, electrochemical series of metals can also be called as cations because metal loses electrons and converts into cations. So we know this electrochemical series. As we move down, the increasing ease of discharge at cathode increases. The ease of discharge at cathode increases. That means if we compare between cation, calcium and zinc. Now zinc being at the lower position in the series, calcium will push this or make this zinc atom move towards cathode. That is called discharge. Discharge of zinc towards cathode. So if we have two cations, zinc and calcium, calcium will discharge, force zinc to discharge at cathode. If we see cations such as zinc and hydrogen. Now between zinc and hydrogen, which one will move towards cathode? Hydrogen, because hydrogen is at lower position. Between hydrogen and copper, which one will get discharged towards cathode? Copper, because copper is at the lower position. So as we move down, the discharge of cation at the cathode increases. Same goes with anions, and we have list of anions over here like sulfate ion, nitrate, chloride, bromide, iodide and hydroxide. And as we go down, the ease of discharge at anode increases. That means out of these ions, hydroxide will easily get discharged at the anode. So I want you to learn this electrochemical series and the preferential selective discharge of ions at the electrode based on electrochemical series of cations and anions. We will discuss more about it in our next class. So this much for today, boys. Stay safe, go through your book and do all things well.